Assalamualaikum warahmatullahi wabarakatuh and good day. Let's have a look into the introduction of DC to DC converter. Previously, we already looked into um, rectifier, which is we convert AC supply into DC output. So that's mean, let's say if we have AC supply, either sinusoidal or square wave, whatever, then we need um, our device to operate using a DC supply. So then we need to use a rectifier. Yeah? But in this case, in this topic, uh, let's say we already have DC supply. For example, 12 volt we get from the battery. For example, kita ada supply daripada bateri. Contohnya, contoh bateri kereta ataupun bateri motorcycle, 12 volt. Then we need to charge our handphone. Our mobile phone is 5 volt, right? So then we need to have a DC to DC converter, which is we need to step down from uh, 12 volt into the 5 volt supply. So that means it's still DC supply, but we change the voltage level and the current level. Okay, so that is what we're going to learn in this topic. Okay, so first let's have a look into the definition. Okay, DC to DC actually meaning for the DC to DC is converting unregulated DC input to a controlled DC output with a desired voltage level. That's mean um, if we want a specific value of output, for example, not just 5 volt, maybe 3 volt, maybe 20 volt, depending on our type of load where we want to use, then we can design our DC to DC converter to suit the requirement of our load. So biasanya application ni kita guna kat banyak tempat macam renewable punya system. Sometimes renewable punya system we have variable input, right, from the solar, for example. Then we want to charge our battery system, and sometimes battery system is not just like 12 volt. Sometimes it's doubling 24 volt, maybe 48 volt. So then our converter need to interface that from input to output. So we need to know how much variation in the output from the solar, and then how much the voltage for the output, let's say for the battery. So and how much power we need to feed into the our battery system. So that's why we call control DC outputs, because we need to measure the output. We need to make sure that the output is following our requirement. Okay, so this is the application for the DC to DC converter. Switch mode power supply, DC motor control, battery charger. So battery charger ni adalah one of the ni lah kata apa, banyak digunakan in the DC to DC converter area. Dan banyak lagi actually application lah, tapi mostly we DC to DC ni banyak digunakan untuk interfacing in renewable system, charging system, switch mode power supply, dan sebagainya lah. Okay, now we look into the concept of DC to DC. Okay, let's say if you have any question, just ask. either put the question in the comment, or you can also raise your hand lah. Okay. Basically untuk DC converter ni, if we have, for example lah, if we have our input, let's say 20 volt, we want our input is 20 volt, for example, and our output is we need the output to be 10 volt or 12 volt, for example. Then we can control our switch here. We can control our switch here, switch on and switch off, uh, depending how much our ratio at the output. For example, if input is 20 volt, output is 20 volt, for example, and output is 10 volt, that's mean switch on cycle and switch off cycle of the switch can be half, right? 50% on and 50% on. Then we will get output. Our output is half lah. So that's the concept of DC to DC. And then in terms of the output voltage, we can get the V out is equals to input V in or Vs here, divided VCE. So that means this one is the Vs is equals to VCE plus V out. So that means V out is equals to Vs minus VCE. If we move the VCE into the side. Okay, so the transistor, okay, ini the common concept lah. Apa ni, switch tu adalah transistor lah untuk dalam DC to DC converter. So the transistor can be modeled by equivalent variable resistor. Okay, so that's mean dia macam ni lah. Kalau short circuit, when the transistor become on, it's a short circuit, right? So in the short circuit, that's mean our value of resistance in that transistor will be almost to zero, right? Very, very low. But when the transistor is switched off, open circuit, that's mean the resistor will be very, very high, almost infinity lah. That's why the current cannot passing through the transistor. So the same concept using the equivalent resistor, variable resistor. That's mean if we reduce the resistance value to the minimum one, the smallest one, then it's become like a short circuit. Then if we increase the resistance value to up to a highest value, then it's become difficult for the current to passing that resistor. So that means it's like open circuit. But when we use the variable resistor, the problem is the loss. Loss in this one. Because our loss is equals to I square, sorry, the battery almost. Okay. Okay, so that means dia punya power loss across that resistor will be quite high lah, I square R, right? I square R. So that's why it's not possible to use the variable resistor as a switch. Okay, then we can use ideal switch, on and off, like this lah. We can use ideal switch like this. So and the good thing is about the ideal switch is the power loss is zero, because whenever we short circuit, no resistance at all. When we open circuit, the resistance will be infinity, and dah tak ada no current, and there is no current at all that passing through that switch. So the loss is zero. So the power transfer is 100% transfer to the load lah. But the problem with the ideal switch, the switch is in the real world application is not possible to use the ideal switch, the normal switch, because um, in the real application we still need to use a transistor or MOSFET that operate as a switch. We cannot use a manual switch macam yang biasa kita jumpa lah, because the DC to DC converter usually operate at a high frequency, more than 1 kilohertz, basically 10 kilohertz above lah. So it's very fast switching, fast switching. So um, it's not possible for our hand to click or to control that kind of switch. So that's why we need to have a control system that control that our switch. So the switching regulator is the basis of all the DC to DC converter. So this means we want to control the switch on and switch off in our DC to DC converter. Okay, next. So this is the basic concept of the DC to DC. So during the switch on, the voltage output we can say is the same as the input. If we look into here, so this is the input side, and this one is the output side. So whenever we close this circuit, that means output will follow the input. That's the basic concept of the DC to DC. And during the off, the output voltage is zero. For the output, we still have input voltage. So ideally, the power loss is zero, since the output power will equal to the input power. Okay, so then we look into this output. So this one is during the turn on output voltage. This one is during the turn off, and this cycle will repeat continuously. So this one during turn on, and this one during the turn off, and then the cycle repeat again, turn on, turn off. And in this figure, we can see that we have how many cycles. This is the first cycle, and this one is one complete cycle, and then we have the second cycle, and then we have the third cycle, third complete cycle, and then the next cycle is not complete. And in order to determine the switching frequency of the system, we can calculate it based on our total one cycle time. So let's say here we have one switching period is T, in second, for example, or microsecond, whatever. So our frequency is our system frequency, Fs, will be 1 over T, 1 over T. So 1 divided by the switching period, and this one is T on is time during the on cycle. That means and the T off is the time during the off cycle. And our duty cycle can be defined as D is equals to time during the on cycle divided by the switching period. T on divided by T, or T on plus T off. T on plus T off is equals to T. So this is, you need to remember that. Or F, we can remove this T and replace with the F. That's why we get this T on times with the Fs. So from this, we can say that T on is duty cycle, D times with T switching period. and D is equals this one lah, in percentage or in. So let's say if our duty cycle is 50%, that means here is 0.5. Yeah? Okay, so this one also awak kena ingat lah, awak kena ingat, and not remember, but you need to know how you get this, and you need to understand how you get this. Okay, and the range of duty cycle, the maximum is 1. Eh? Maximum is 1, the minimum is 0. So that means the cycle can only operate within 0 to 1 only. So that means kalau kita nak operate, kalau kita increase the cycle maximum pun sampai habis sampai sini je, dia akan bersambung lah. So that means V out ni akan sentiasa on straight je. So that means that one is 100% duty cycle lah. But usually when we design our DC-DC converter, it need to be dia ada a specific value, dan normally we're not going into 90% to 100% punya range lah. Usually we operate maybe 30% to 60 or 70, something like that. Otherwise kita akan hadapi masalah dengan ni lah, awak control dengan loss. Okay, then we look into the average DC output. So average DC output is V out equals to Vs times with Vd. So this one is the basic concept of the DC-DC lah.